At last, we are learning a new shape, ellipses. Ellipses are kind of like ovals. You'll see them when you trace out the paths of planets around the sun. They actually don't move in a large circle, but in an ellipse. So an ellipse is the set of all points that would be drawn like this. Suppose you tie a string to these two fixed points, fixed point 1 and fixed point 2, and then I kind of attach a length of string to those 2 points, and then I take a pencil and kind of like use that string as a guide all the way around. This would draw an ellipse. So an ellipse is the set of all points that have basically the sum of PF1 and PF2 is always going to be a constant, right? If I add these together, it will always be the same distance, right? Because I'm using that same string to go all the way around. So I can have an oval that's kind of sideways or an oval that's kind of taller, right? And these are both ellipses. PF1 and PF2 we're going to call focal radii. So let's go ahead and take a look at an equation where we would be graphing an ellipse. So I have x squared over 25 plus y squared over 9 is equal to 1. This looks a lot like a circle, but it's sort of like one is going to be a little bit more stretched than the other. But it is going to have a center just like a circle, where this center will be 0, 0, because there's no x minus h, y minus k, right? I just have x squared and y squared, so the center is 0, 0. So think of what would make that x squared term 0 and what would make the y squared term 0. In this case, 0, 0, right? 0, 0 is not actually a point on the ellipse, on the actual graph, right? Because if I plugged in 0 for x and 0 for y, I would get 0 equals 1, which is not true, right? So 0, 0 is not actually a point on my ellipse, it's just in the middle of my ellipse. So the very first step in graphing the ellipse is to find the x and y intercepts. So I'm just going to start with the x intercepts. And let's go ahead and set y equal to 0 in order to find that. So I would have x squared over 25 plus y squared over 9, which is going to be 0 over 9, is equal to 1. And then I have x squared over 25 equals 1. So x squared is 25. So x is plus or minus 5. So these are my x intercepts, right? Now you can kind of think of this as being 5 away from the center, right, in the x direction. So now I'm going to find the y-intercepts by setting x squared equal to 0, so I just get 0 plus y squared over 9 is equal to 1. And if I do that, I get y squared over 9 is equal to 1, y squared is 9, y is plus or minus 3. So those are my y-intercepts. Okay, so I'm going to kind of box both of those, and we're going to draw these on a coordinate plane. So let me just quickly draw these axes for you. There we go, instant graph. Okay, so we are going to plot these x-intercepts. Okay, but think of them as just the square root of what's underneath the x squared and the square root of what's underneath the y. And you can kind of plot them that way. So x is equal to plus or minus 5, right? And then the y-intercepts are plus or minus 3, so I plot all those points. The next step is I'm going to draw a dotted line and make a box here. Now this is not entirely necessary for when you're drawing ellipses, but it's going to be very similar to what we're going to do for hyperbolas later. So go ahead and just bear with me, draw the box, and then we're going to draw the oval shape inside that box. This is our ellipse. So we have finished graphing the ellipse, but we might want to find the foci, right? Remember that the foci are the things that we use to actually draw the shape, right? The two focal radii being always adding up to the same number, right? Because of that string that's tied to both of the focuses. So let's go ahead and label that distance that the foci would be as C, and then I label B and A down there, and then I'm going to label this R. Okay, so that's one of the radii, right? I'm going to draw a radii on the other side. I've connected it to the wrong point there, but I'll fix it. And then we have a radii on the other side, and these make kind of like two right triangles, right? So I'm actually going to redraw that R here. Okay, so R is the hypotenuse of a right triangle that you see there, and it's going to be equal to B squared plus C squared, where B is just sort of that half distance and A is that other half distance of the box, right? And then I also have that 2R is going to be equal to C plus A, right? And then plus that little part, which would actually be just A minus C. You can pause the video and try to figure that out for yourself. But basically what I'm going to get is that 2R is equal to 2A, which means I can replace the specific instance of R equaling R squared equaling B squared plus C squared with A squared equals B squared plus C squared. And I could solve it for C and say that C squared is equal to A squared minus B squared. Okay, so that's that A squared is going to be right underneath the X squared right there, and my B squared is going to be right underneath the y term there. So 9 is actually equal to b squared in this case. Okay, so in order to find c squared, right, I'll just plug those two numbers in. C squared is equal to 25 minus 9. Those are the two bases that I saw. It's going to be the big base always minus the small base, okay? And you can kind of think of that in that general terms. So therefore, C is going to be equal to plus or minus 4, okay? Which means that my foci are located at 4, 0 and negative 4, 0. Okay, so don't worry too much about all of that process I did with deriving. Basically, just know that 2a is always going to be the sum of the focal radii, okay? And a is always going to be that kind of the bigger base, whatever it is. And then c squared is always going to be equal to a squared minus b squared, the big base minus the small base. So let's go ahead and apply those two things in this next example. So we're going to take 2x squared plus y squared is equal to 8. Now notice for a second that I don't have that other side equal to 1. Okay, so the two kind of like standard forms for the parabola are going to be x squared over a squared plus y squared over b squared is equal to 1, or x squared over b squared plus y squared over a squared is equal to 1. Now these shapes are going to look different, right? But a is always going to be the bigger number. So always think of the bigger number being a, right? Where 2a is going to be the sum of the focal radii, and then I'm going to get this equation c squared is equal to a squared minus b squared. So this is kind of a chart that we'd have. If the bigger number is under x, then that means it's kind of going to be like a longer in the x direction type ellipse, and then if the bigger numbers under the y squared is going to be like kind of like a vertically situated oval. So anyway, I divided by 8 by both sides to get the one side equal to 1. A squared is equal to 8 and b squared is equal to 4. So let's talk about what these mean. So I see that my 8 is underneath the y squared. So that's going to be how much I kind of go up in my y direction. And then b squared, which is 4, is underneath the x, right? So I'm going to go over by the square root of that in the x direction. Okay, so I take the square root of both of those bases in order to figure out how much I'm going to go away from the center in x and how much I'm going to go away from the center in y. This is just finding the x and y intercepts. It's just a different way of thinking of it. You can just take the square root of both of those bases, okay? Because I have, a squared and b squared, and a is kind of like my vertical direction in this case, and b is my horizontal direction. Okay, I draw my box and then I connect my oval. When I do that, I'm going to now find my foci. So c squared is equal to a squared minus b squared, which is 8 minus 4, which is 4. So c is equal to plus or minus 2. And the foci are always going to go along the direction of where what's called your major axes is. That's just where like the longer part of the oval is, because there's always a short part and a long part with an oval. They would never be equal, otherwise that would just be a circle, right? And the foci are always going to go along the long direction. So let's go ahead and do another example. Let's suppose we have two x-intercepts plus or minus 3 and then two y-intercepts plus or minus, let's say, 4. And I want to figure out what the equation for this ellipse is. So the x-intercepts I might plot and see that they are at plus or minus 3 right there. And then I have plus or minus 4 right there. So I see that this is an ellipse that's kind of standing tall. It's a little bit vertical, right? So I am going to plug these into the equation. So I kind of set it up with x squared plus y squared. They're going to have some bases. Underneath the x, I'm going to put 3 squared, right? And underneath the y, I'm going to put 4 squared. So I get x squared over 9 plus y squared over 16 is equal to 1. Okay, so you see that that's the a right there, and then that's the b dimension, right, in the picture. B was 3 and A was 4. So let's go ahead and do another example. We'll go through this much slower in class. Let's suppose I have 0, negative 5, and 0, 5 are my foci, and I also have 20 is equal to the sum of the focal radii. So the sum of the focal radii, if you recall, 2a is equal to the sum of the focal radii. Therefore, 2a is equal to 20, therefore a is 10, and a squared is 100. Okay? And then I know that a squared minus b squared is equal to c squared, so I might plug in my a squared and my c squared to get that. Okay, so first let's go ahead and look at this. So here's my first focus and my second focus. See how they're along the y direction where c is equal to 5, right? Because that's kind of like the distance from the focus to the center. So I'm going to square that and it's going to be 25. I'll end up getting b squared is equal to 75 or b is equal to 5 root 3. But now I just have to figure out, okay, which one has the bigger base? So I know that this is going to be longer in the y direction, because the foci are in the y direction with respect to each other. So I would put 100 over y because it's in the longer direction, and then the short direction I would put 75 under that because x is going to be a little bit smaller. Good luck on your homework and have a great day.